Math is clean, math's easy when you're doing math with Miss Lee.
Welcome to my lesson on factor by grouping. In this lesson, I'll cover three methods. The first method using trial and error, or what you might call reversing FOIL. The second is an algebraic method that bears the name factor by grouping. And the third, using boxes to organize my work. I'll factor the expression x cubed plus x squared minus 9x minus 9 by grouping with the trial and error method. First, think of each of the four terms as part of the acronym FOIL. So whatever I place in the first positions needs to multiply to equal x to the third. I'll use x squared and x as my factors of x to the third. The outer terms need to multiply to equal x squared. Since I already have x squared in one of these positions, the other factor must be positive 1. And to make my inners and last terms multiply to negative 9x and negative 9 correctly, that last empty space must be a negative 9. If I multiply these factors back together, I get x cubed plus x squared minus 9x minus 9. Then as a last step, x squared minus 9 is a difference of squares that factors further, as x plus 3 times x minus 3. This method can be more difficult depending on the expression we're factoring. If you end up using this method, there may still be a bit of trial and error involved in getting some of the terms to work out correctly, and you may not find it easy to work in order, so you may need to work depending on which terms seem easier to match. Now I'll factor the same expression using the algebraic method classically called factor by grouping. Start by grouping the terms into pairs and finding the greatest common factor of each. I'll factor the x squared out of the first two terms and the negative 9 out of the last two terms. The expressions in the parentheses should match. If they don't match, then we've either made a mistake or the grouping method doesn't work for this expression. To complete the process, write the matching parentheses once, and then fill in the other set of parentheses with the terms that are outside the parentheses from the previous line. And again, the x squared minus 9 would factor further. Now I'll factor the same expression using what I call the box method. First, I'll start by drawing a 2x2 grid so that there's one box for each term. Place a term in each box, working in order from left to right and top to bottom. Now working in any order, I'll place the greatest common factor of each row to the left of the row outside of the diagram, and I'll place the GCF of each column at the top of each column outside the diagram. The greatest common factor of the first row is x squared. The GCF of the second row is negative 9. And then for the first column, common factor is x, and in the second column, the only common factor is 1. This means our factors are x plus 1 across the top and x squared minus 9 along the side. As in the previous two methods, we'd still need to factor the x squared minus 9 further. You should note that if you use this method, if the entire expression x cubed plus x squared minus 9x minus 9 had a greatest common factor in all four terms, we would need to take that common factor out first before we could use the box method.